For this lesson, we're going to be looking at some of the applications of completing the square. So we're going to go through a few different types of word problems and go through the steps of how to solve them. So the first one says, a rectangular field is to be enclosed on one side by a barn and on the other 3 sides by 400 meters of fencing. Determine the dimensions of the field if the area is to be a maximum. So the first thing I want to do is I always want to draw a diagram. So anytime that we have some sort of word problem, it's always a good idea to start with a diagram just to organize our thoughts a little bit. So here's my barn right here. And then I'm enclosing a rectangular area. So it's going to look something like this. Now, I know that we have 400 meters of fencing in total, and I want to maximize this area. So I'm going to let these sides be my width, and then I have my length. Now, I have 400 meters of fencing total. So if I use up W for this side here, and I use up W for this side here, what I'm left with for my length is 400 minus the 2W that I used for those two sides. So now that I have my dimensions, I'm going to start and figure out the maximum. So anytime we see the word maximum or minimum in the question, we know that we are going to be looking for the vertex. And right now, that means completing the square. So we're looking for the area. So let's start by writing out our area equation. So area of a rectangle is equal to length times width. And our length, we said, was 400 minus 2W, and our width was just W. So let's go through and just multiply that W in. So that gets distributed like that. And then I have 400W minus 2W squared. Now what I'm going to do is I'm just going to rearrange that. We always want to make sure that everything is in the right order before we get started. So that negative 2W squared will go at the front, and then I have my 400W. Now, because I'm looking for a maximum, I know I'm looking for a vertex. So that means I need vertex form. So I'm going to go through and complete the square. So remember, we put our brackets around our first two terms, and we factor out the coefficient in front of the W squared. So factor out that negative 2, we're left with W squared minus 200W. And now I need to find that magic number that's going to turn this into a perfect square trinomial. So I use this one. So I have negative 200 divided by 2 all squared. So we have negative 100 all squared, and that will give us 10,000. Sometimes when we have these more real life examples, we are going to be working with bigger numbers. So don't stress if you have some big numbers, just follow your steps through just like before. So now we take that 10,000 and we're going to add and subtract it in the brackets. So we add our 10,000 and we minus our 10,000. And now we need to take the negative one and it needs to leave. But remember, when it leaves, we have to multiply it by our A. So we're going to have to multiply by negative 2. So that will leave us with negative 2W squared minus 200W plus 10,000. And when that comes out, we have plus 20,000. Now, sorry about this. I'm running out of room, so I'm going to have to move it up here. Hopefully you can still follow along with what's going on. Now I need to factor this stuff in the brackets. Because of how we've set this up and that magic number we found that's in the pink, we've made it a perfect square trinomial. If you're struggling with that part, you can always use decomposition, but from an efficiency perspective, noticing that it's a perfect square trinomial is very beneficial. So I'm just going to factor that. Our -2 still hangs out here. And then I have w minus 100 all squared plus 2,000. So if I think about what this graph represents, I have my area and my width. So if I'm looking at my vertex, I have 120,000. Because my equation is using area and width, this is a width value, this is a area value. So now we need to find our dimensions. So using our vertex, we found our width, but we need to find our length. So remember, from way over here, we have a value for our length. So we're going to use that to find our length. So length will be equal to 400 minus 2 times 100, 400 minus 200. So our length that will give us our maximum is 200. And if you remember from grade 9, that makes sense because for a three-sided rectangle, our length is always double our width. So in grade 9, you would have just been given that three-sided rectangle, okay, length is double my width. But in grade 10, we can actually figure it out. So then you need to put a little therefore statement. I'm really running out of room, so it's not going to happen, but please make sure you're doing that on your quiz questions. That would be a big help. Okay, let's start with our second example. So that's an area example. Now we're going to do a number example. So we want to find two integers whose difference is 12 and whose product is a minimum. So the wording here is kind of confusing. So two integers whose difference is 12. So remember, difference is telling us subtract, and whose product is a minimum. So in other words, there are loads and loads of numbers that when subtracted equal 12. There are infinite combinations. But we want to find ones that their product, so when they're multiplied together, is as low as possible. So let's start with our let statements. So I'm looking for two integers. So I'm going to let x represent the first integer. And now I know that there's a difference of 12. So we're going to let x minus 12 represent the second integer. So now that I have my let statements all set up, I now want to think about what I'm looking for. I'm trying to find the numbers whose product is a minimum, and product refers to multiplication. So the product of these two is equal to my first integer multiplied by my second integer. And now what I'm going to do is just distribute in that x. And now I'm looking for a minimum. So when I see that word minimum, it means I'm looking for the vertex. So anytime I'm looking for a minimum or the vertex, it means I'm completing the square. So first thing I do is I put brackets around my first two terms, and then I factor out as much as I can in front of that first term. Because it's just a 1, I just leave it. Now I need to find that magic number that turns this into a perfect square trinomial. So I use this thing here of -12 divided by 2 all squared. And that will give me 6 squared, which is 36. 6. So now I add 36 and I subtract 36. And now I have to move out the negative 36. And I always just check that there's nothing over here that I have to multiply it by. Because we don't have a number over there, I don't need to worry about multiplying it by anything, or I'm basically just multiplying it by 1. So now I'll have x squared minus 12x plus 36 minus 36. And now what I'm going to do is I just factor the stuff in the brackets. So we'll have x minus 6 all squared minus 36. So that is our complete square. So that's our vertex form. And now what does that tell me about our numbers? So remember, I'm looking at the product and x. So when I find my vertex, which is 6, negative 36, this represents my x, and that represents my minimum product. So now that I have my x, I have x equals 6, I need to find the second integer. So I do x minus 12, and that will give me 6 minus 12, which is negative 6. So I can say, therefore, the two numbers are 6 and negative 6. So our next one here is a motion question, so a little bit different. There's a few pieces to this, so bear with me because I don't have a ton of space. So an angry bird is shot from a slingshot. Its height h in meters after t seconds is given by the equation h equals negative 5t squared plus 35t plus 2.1. The first thing we need to find is at what height does the angry bird start? So let's draw ourselves a little picture here. So we have time in seconds down here, and we have height up here in meters. And again, remember this is just a sketch, so it's not going to be perfect, but it helps us to visualize things a little bit better. So our angry bird is shot from a slingshot, and it goes like that. So we want to figure out what height does it start at right here. Now, there's two ways I can find this. The first option is that our c value here is always our y-intercept. So you could just use that if you want. But the way you can always do it if you ever forget is we're just going to sub t equals 0 because we're trying to find an initial value. So when I do that, I'll have h equals negative 5 times 0 squared plus 35 times 0 plus 2.1, and I get that the height is 2.1 meters. So therefore, it is shot from a height of 2.1 meters. So because I found that, I'm just going to label that on my graph just to keep our sketch as accurate as possible and give us a bit of a visual. Okay, next for B, we need to find when does the bird reach its maximum height. Now I see this word maximum. So that word is telling me that I'm going to be completing the square and I need to find the vertex. So let's write out our equation. So again, our first step, brackets around those first two terms. Next, factor out the number that's in front of that t squared. Next, we need to find that magic number that will turn this into a perfect square trinomial. So we're going to use this -7 here. And that will give us 12.25. Don't worry about having decimals for this. We have decimals in the question with that 2.1. So decimals in your answer, totally fine. So now we add and subtract that in the brackets. Now we need to move this thing out of the brackets. And remember, when that happens, we have to multiply by this number. So we have to multiply by -5. Everything else just stays the same. Then when that -12.25 comes out of the brackets, it's multiplied by -5, and then we have 61.25, and we solve that plus 2.1 hanging out at the end. Next, I'm just going to collect those like terms to simplify things. And that will give us 63.35. And now I just need to factor the stuff in the brackets. Now, this is where the factoring gets a little tricky, and the fact that it is a perfect square trinomial really matters. So because we made a perfect square trinomial, I can square root this thing. So if I square root 12.25, I'm going to get 3.5, which makes sense from over here. So that will give me -5 t minus 3.5 all squared plus 63.35. So I know that decimal part is confusing, but remember, this is a perfect square trinomial. So because we have a squared minus 2ab plus b squared, we can square root that 12.25, and it just goes right here. Okay, so now that we've completed the square, we can find our vertex. So we have height and time. So our vertex that we're given is 3.5, 63.35. And based off our equation, this is a time value and this is a height value. So what question B is asking us is, when does the bird reach its maximum height? And when I have 3.5, 63.5, it hits its maximum height at 3.5 seconds. Therefore, the max height is hit at 3.5 seconds. Now C just continues from this very directly. So C is asking us, what is the max height? And we have that right here. So I can just say, therefore, the max height is 63.35 meters. Now, the last one is, what is the height of the bird after 2 seconds? So 2 seconds is a t value. So that's telling me to sub in t equals 2. So that's what I'm going to do. I'm just going to rewrite my whole equation with t equals 2. And it's up to you. You can sub it in the vertex form or the original. It does not matter at all. As long as you did all your math right, they represent the exact same thing. So I'm going to sub it into the original, but it really doesn't matter. So all I'm doing is, instead of writing a t, I'm just putting a 2. Start with my exponents. You can do more steps at once if you want to. I just want to make sure everyone knows where all our numbers are coming from. And that will give me -20 plus 70 plus 2.1. And that will give us 52.1. So we'll say, therefore, at 2 seconds, the bird is at 52.1 meters. And if I look at my graph, if I'm at 3.5 seconds at 63, well, before that, it should be lower than 63.5, so that number makes sense. So there's some to try below. Some of them are hard, so go through and do your best, and then look at the solutions. Remember, if it says maximum or minimum, it's telling us to complete the square.